Thank you everybody for sticking around. It's been a long day, but a lot of interesting presentations. I will mention that the SimCenter does use Python, as Michael introduced, and we also use Roger's ground motions. They're an option in our workflows. So I won't mention the giant team of people that work in the SimCenter. I'm just the co-director, so none of the work is mine. I kind of push paperwork around and hire people, but there's a lot of interesting things that we do. I just wanted to start out with our mandate here, which is really to produce software. So we're not a research organization per se. We produce software for people to do research. It is supposed to be open source. So everything that we do, you can download from GitHub. You can also download pre-compiled sort of executable types of things for us, but you can also get the source code. And that's a big part of the research aspect, because you're going to want to change things that we do with your better models, your better research, and so it's plug and play in that sense. And it's supposed to account for uncertainty, so we use Dakota as our uncertainty engine right now, but we have options, and we're working on adding new uncertainty engines into the system. The framework's very flexible. As I mentioned, it's also scalable. It runs on HPC resources in particular. Everything has an option to run down a TAC, so if you have big problems, it'll do that. The framework's fully seeded out, in particular for doing regional calculations. So everything's there, so you can, if you're working on a small bit of research, you can pull that piece out, you can put your own in, but you can see how it affects the global calculations that the society really cares about. So you can see the impact of your work if you're just working on some component type work. All the tools, we release them in this framework. It's up on DesignSafe, so you can download it. The other thing that we do, I want to talk about today, is that we're also in charge of trying to build an ecosystem, people doing simulation work in natural hazards, and so we run workshops and we produce webinars and things like that you can find on our website. So, but what I want to talk about today is our software. So we have these research tools. They all have these sort of logos, and I'll kind of walk through some of these, and I'm going to talk about the ones that we have already available and what's going to be coming out this year. Everything runs on your desktop, but it also hooks to TAC, and so it can also run larger calculations on TAC just by pushing a button. You have to get a DesignSafe account, but other than that, you can do both those types of things. Okay, so let me start with the first piece of software. This is we call QuoFem. It had a different name before, but it does uncertainty quantification and optimization, and in particular around finite element calculations. It has a lot of forward methods, Monte Carlo methods and things like that, sampling and surrogate models. It also does inverse problems, so it'll do parameter estimation to you, maximum likelihood estimates, and a posteriori estimates for you. It has form and SORM in it if you want to do those types of calculations. It also does global sensitivity. So it's all built in there for you, so you can just run it. It has it. All these tools I'm mentioning right now, they have UIs, so they're relatively easy to use. Coming this year, we're going to have online parameter estimation, new Monte Carlo methods, design of experiments, and we're also going to open up the uncertainty quantification engine so you can change that engine. Right now we rely on Dakota, which is good for some things, but it's lacking in other areas if you've used that. So we'll also have rare event methods in there. And we also, Michael Gardner recently, he actually pulled out the FEM code and stuck in his own rockfall model. It's a relatively flexible package. So, and I think he has a poster on that that you can look at this evening. So this is QuoFem, and it's in its second release. The next tool I want to mention is we have wind engineering tool with uncertainty quantification, WEUQ. And you have a lot of loading options here. You can have stochastic wind generation. It also automatically will go off to Vortex winds and pull out of the database there. It'll also pull out wind loading from the TPU database. And so you have a lot of different options for selecting your loads in the system. The uncertainty quantification methods that are available right now are only the forward propagation methods that are in QuoFem. And it will also do model generation for you, so you can have nonlinear shear buildings, or you can bring in your own OpenSeas models for the building model here. Coming in year 4 will be fully coupled CFD. Right now it's just one way, so basically rigid buildings. But coming in year 4 will be fully coupled. And also we're going to have surrogate modeling options available to you because CFD calculations are very expensive. So those are some of the features they'll be coming out in year 4. And also we'll be making available more of the uncertainty quantification methods that are currently inside QuoFem available to you. So you can do some pretty interesting wind engineering calculations. This is relatively new, but it's certainly fully functional and available for you for downloading. We also have an earthquake engineering tool. So these tools right now that I'm describing, they're sort of single building tools. I'll talk in a little bit about regional tools. So we have an EUUQ tool. And again, here you have options for loading. So you can have stochastic loading models. You can read in Rogers' Bay Area calculation if you want to do it that way. It also interacts with Pure NGA West. And it also has a site response component. So if you want to propagate something from rock up through a column, 2D and 3D, with a whole bunch of different type of models. You can set the layers, the water table, all sorts of things. There's a UI for that, to do that. And again, it has the forward propagation methods from QuoFem for doing the uncertainty quantification. And it has the same building models that the WEUQ does. Some interesting things that will be coming out in year 4 will be random fields for the site response tool. So if you want to have random fields for the properties, domain reduction that we heard from Rogers will also be there. And we'll also add in the NGA East database, so you can get those records if you're interested. Surrogate modeling again. So especially if you want to do uncertainty quantification, is really going to be needed if you're doing large types of calculations. So those are a few of the things that will be coming out in year 4 here. Another tool that we have is a performance-based engineering tool. And so this one will allow you to do performance-based engineering. The UQ methods are the ones that you can get from the EUQ tool, and the same thing for the events. And the damage and loss estimations that are done in this PBE tool, you have options of sort of high-fidelity FEMA P58, and you also have HAZ's damage and loss type functions. And so this is the work of Adam Zarnowski at Stanford, is one of the postdocs inside the center. And there's also options for user configuration of the damage and loss model. So if you don't like the ones that we have, you can put your own in and do research there. One of the things that will be coming in year 4 is extending this to allow, it works right now for the earthquake engineering type of calculations. We'll be having the wind damage and loss models in there too. And there'll be ones for lifelines and things like that also coming along as we move out into year 4. Another product that we have is Pelican. This is actually the back-end thing that is doing the PBE calculations. This is Adam's work here. This is a library that you can use. It does uncertainty for the structural response, time-based assessments. It has a user input system that's supposed to be friendly, and it also has a system for doing auto-population. So when you're doing these types of calculations, there's a lot of data to be entered, and so that's also there. There are a whole bunch of updates that will be coming in year 4. I guess maybe I'll just point out one here, which is the lifeline damage and loss assessment aspect, which I think is pretty interesting. And also, it will be extended out for the storm surge and tsunami types of calculations. So these are all tools that we have available for you to download, and they're essentially geared towards single building types of calculations. The thing that we're really moving towards and trying to push on is high fidelity regional simulations. And one tool that will be coming out this year is the RDT tool. And this is basically a front-end tool. It's a UI tool to some things that we've already released. I think Greg last year talked about RWhale, which is our regional workflow for hazard analysis and loss estimation, which runs in the back end. That's the work of Wael El-Haddad, which kind of orchestrates regional simulations for you. And I just want to go through a couple of the things that we have available for doing regional simulations that we'd be really excited to see people using. So one of the things I think that's really important, everybody who does this type of thing already knows, you need to have a building inventory when you're going to do a regional simulation. And we don't explicitly release tools for generating inventory, but we have ways of generating inventory. So if we've already done your region, there'll be an inventory. But we also have a webinar that teaches you how to scrape the web. So using a Selenium plugin for a Chrome browser, we'll go through and say take tax records and just simply scrape up all the data in the tax records and try and find all the parcel information and then build a building information model for you. And so YL again has created a webinar that shows you how to do this. And there's a lot of open data out there. Probably homeowners are not aware of this, maybe. But so everything that we do in the regional simulations is parcel level. It's not county level type of stuff. It's actually your house or apartment building or something like that. Now, one of the things that happens when you do this is that you end up with missing data. So whether you scrape it from tax assessor records or you're using Google Street View to scrape the data, you end up with missing data. And so Charles Xiaofeng Wang has developed a system by which you can take the scraped data, see where there's things missing, and use an AI algorithm, machine learning algorithm, to fill in that information so that you have a complete record. Okay, and so that's a combination of two things, Braille's and SURF, which does this. So SURF fills out the spatially, it gets you a spatially correlated fill-in in your missing data. And so that's available also, and is part of this system here. Another tool that's coming is temporarily named EQSS. I'm sure it'll have another name. We have a naming scheme. There's a book on the desk of sea animals that people try and use to name their various pieces. But this is a mock-up that's been done. It allows you to select a site. So he's going to select here Anchorage. It'll bring up Anchorage over here on the side. And then you can scale the region that you're looking for. So you can move the map around. You can grab the corner here. You can drag it and decide where you want to do your earthquake simulation. In particular, you want your ground motion records. You can select your sites, what type of event that you want, and what kind of ground motion prediction equation that you're interested in, for instance. And it will then go ahead and run that prediction model. Then it will go off, say in this case here, to Pier MGA West, and it will find the records and get them scaled appropriately on the grid that you've selected. So you can set the grid here. He selected it 20 by 20, and I guess, okay, it's running now. Is this running in real time, Lyle? Yeah. So the video here is real time, so we'll give it a second here. So what does it say? I can't even read it. 58% right now. It's going to jump in a second. And so now he has the grid. He can click on the points. You can see the response spectra in the corner is scaled appropriately. You can see the mean and then all the individual records that it's pulled for you so that you can then do your regional simulation, and it's done all the way across this entire grid here. So it's a nice sort of UI for getting that type of information, for doing the regional calculations. To help people get into regional calculations, we have test beds that we're releasing. Last year, Greg talked about the San Francisco Bay Area test bed, so I won't discuss that today. But we've released another earthquake test bed, which is Anchorage, Alaska. And we have two new ones that will be coming out this year, a storm test bed in Atlantic City, and then also a Lifelines test bed for a water network in Memphis, Tennessee. The way these test beds work is you have to chain all the pieces together, but the interface allows you to switch out the fidelity that you want for each piece. So you have the building information model, you have the ground motion, the models for the buildings, and how you're going to do the damage and loss. And you can change any of those puzzle pieces to have different types of fidelity. So in this particular case here, we're going to change the ground motion from the recorded ground motions to the simulated ground motions. And then you can run the calculations to see what type of variance and difference they are. So this is really opening up a research opportunity here. This is just a quick result. We did a very fast calculation. It's not verified, but you can see the differences that you can get from recorded ground motions and simulated ground motions. If you look at the red tags, for instance, they went from 3,800 down to 600 using just two different ways of doing the ground motion. And we will note that Anchorage identified 750 homes that were significantly damaged or buildings. So there's a lot of opportunity to do interesting research here with these types of codes, and you're invited to do this. The testbed is published. This is with ArcGIS, I guess. And so if you take a picture of that QR code with your phone, it'll actually take you to this thing, and you can play around with it. You can navigate all the information and calculation here for the testbed. So that's available to you. So it lets you zoom in, move around, look at different information. It's a pretty cool way to release your results. Let me just talk about the Memphis Testbed here. So this was a Lifelines testbed. So it's a 7.5 event in Memphis on the water network. That's shown there is just the mean peak ground velocity. One of the nice things about the testbeds here is that we're doing this stochastically, so you have realizations that generate the means, but one of the things that we're really pushing on is taking into account correlations in ground motion. So you have one realization. If you zoom in on it, you can see that there's a clear spatial correlation to the PGV there, and so we take that into account to generate correlated results for the damage. So we're getting something that's closer to the reality, and then also you get better information on the losses. And so when you go to report what happened, you actually can compute the distribution, say in this case here for expected repair time. You have an expected repair time of about a year there, but you can see that you have a very interesting distribution here, and allows you to make a better decision of what's going on. In the regional simulation world, in terms of software that's coming right now, we're doing water networks buildings for hurricanes and earthquakes. We're going to move that out to handle tsunamis. Other types of networks and lifelines will be coming. And we have sort of different types of efficiency. The lower efficiency is sort of hazard space type stuff, and the higher efficiency is the FEMA P58 type of analysis. And we're trying to fill out this cube of methodologies. So let me go ahead and close here. This is the peer meeting. I really want to point out that we're really leveraging a lot of past peer work. OpenSeas is integrated into this, the NGA databases and things like that. And we're really trying to push out into the future with regional simulation and new types of hazards, so not just earthquakes. All the software is open source, so you can go to the SimCenter website at DesignSafe, or you can just go to GitHub if you want to get the source code itself and not just the executables. The center is open for collaboration. We're really interested in interacting with researchers, so please contact us about that. If you are a student and you are graduating, we are also looking to hire people. We're really interested in people that have a passion for hazards and really know how to code. So we're looking for those two things. And also, if you're not as aged as me, you probably have a Twitter and Facebook account, and so we have a Twitter feed and we have a Facebook account, so follow us there. And we have lots of webinars and things like that we put out, so leverage that to learn new things. And most importantly, we're looking for people to take the tools and contribute back features to our tools. So everything's open, and we're really interested in working with everybody. So thank you.